Okay, so in this video, we're going to demonstrate the adaptation of a single-user macromolecule visualization tool for use with groups of people working in environments that contain tabletop displays and multiple wall displays. So this is JMOL, which is a molecular visualization application. And we have it running on the table, and we've added a few gestures for manipulating the camera around this molecule. So with a single finger, I can reach out and I can tumble the object. What's nice about a molecule is that it doesn't necessarily have an up, so this is never really upside down for any member working around the table. With two fingers, I can grab and stretch to zoom in or zoom out. With my hand, I can grab the table and pan the molecule around. And then finally, I can rotate the molecule around the center of the screen, rotate it in the image plane. So in this case, we're looking at hemoglobin. And I can pull up the JMOL menu and choose a different scheme for rendering this molecule. We'll choose a cartoon presentation. And what I'm going to do is take this view and create a bookmark so that we can later return to this view if we're in a group and discussing this. So I have down here in front of me a small control panel where I can grab a picture of the current view, drag it out, and just drop it in this space to create a bookmark. So now, if we modify our view and perhaps change the presentation, we'll create a second bookmark, and at any point we're able to return to our previous bookmark by simply selecting that. So this is important for supporting forks in a conversation and being able to return to previous points in a conversation. If you look up at the walls behind me, you'll see that we have a second and third machine running synchronized views of the same molecule. They're running separate instances of JMOL, and we're using the network to pass messages so that these different instances of this application are all synchronized. So that as I change the view on the table, what you should see behind me is this, the corresponding view being displayed on either of the two walls. And now back down on the table, you'll see that all of the walls in my space also have a proxy on the table. And in the way we could open up a bookmark on the table, we could take these bookmarks and drop them on the walls behind me so that our space is populated with different views of this molecule. And even with different views displays, you'll see that our view is still coordinated. And this allows a team of researchers to view a molecule with some of the many different presentations that we're able to use to render one of these proteins. Put up a trace of our backbone, and what we have now is our backbone structure on the table, a visualization showing the interface between the surface of the molecule and the solvent, and finally a cartoon presentation showing the active site and the binding of our iron atom to our oxygen molecules. So one problem with tabletop displays that you interact with your hands is that your fingers are not terribly good at performing accurate selection. So in this case, looking at these enzymes, we see that there are tens of thousands of atoms in these molecules, and it would be very difficult to select structures or individual atoms when using your finger. So to help with this, we've built a custom control panel of sorts that's networked to our tabletop machine. And this application includes both a method of selection and a palette of sorts for changing the appearance of these structures and atoms. So over here on the left, we have a very long list of residues in our structure, separated into the different chains in the PDB file. So with a tap of this pen, I can select either an entire chain, individual structures within that chain, or even individual residues in the sequence. Now, once any of these structures or atoms are selected, I can change their appearance on the table using this palette here. So we can change the appearance of individual atoms. We can choose between a couple different common styles of representing proteins. And of course color our structure, show its surface, or any number of other visual representations.